All right, so because we have our implementation done, we are going to need to write our header file. And our header file is where we're going to tell every other C file that we interact with what each function is and its parameters. We're also going to define, we made a custom data type here with XCP result T. So we're going to need to define that before we try to call it. So let's go ahead, save this. And we will just make our header. So I'm calling the actual function composition file .c, and the header is going to be .h, which is the standard C convention for this. So the first thing that we want to do is a define guard. So if the n is not, so if not defined, we want to define, or if not defined XCP header, then we want to define XCP header. This is an inclusion guard so that you don't recursively include the same thing over and over and over again. We're going to want some standard things. So the standard definitions and include the standard integers. Then there's kind of a weird thing you got to do with C++. So C++ has this weird name mangling thing that it does. So whenever you compile this, C++ is going to call from compiled C code, but C++ mangles names. So you have to define that something is, if something is C++, then we have to extern C. So we're going to extern C whatever is in between these guards if it's C++, which means it will skip the name mangling. I have many opinions on C++. You will probably never see me write it unless there's like a dire circumstance. So let's save this out real quick and go ahead and look back at our C file. So I defined a couple of things in here that we're actually going to need in the header file instead of here. So I'm just going to copy those and we'll remove them. We'll put them in the header file. So we have our key size, non-size, and block size. Later, we're going to come back to this and we are going to add to that because we will need them for XChaCha and Poly1305. But for now, this is enough for us. The next thing we want to do is look at our custom data type. So we called it XCP result T. So there's going to be a couple codes here. The first is what happens if everything goes as we planned. What's the return code? Usually we want that to be 0. Then every result other than that, we want to have some kind of unique error code. And the reason for that is we want to know exactly what went wrong. So if everything goes okay, then it'll be 0. If there's a parameter error, so remember we defined or said that we were returning param errors. So what we want to do is define that with a numerical value. So if we have an XCP param error, we'll make that 1. So later when we include the other cha-chas, well, specifically the authenticated methods, we're going to have an authentication failed. So that means either something was corrupted or tampered with. So we'll just call that auth failed, and we'll just have that defined for later. We'll make that 2. And then another common error that we're going to have in things like this is we're going to want this to be constant size. So this is basically a calculator. So let's say you have 40 bytes of information, and then you want to go through your cha-cha calculation. You only want to take up 40 bytes. Now this will need a little bit of scratch space, so you might have some buffers here, and you might have 80 bytes on the stack or the heap, depending on where things are allocated, but this might have, because you're going to have the working state, which is going to be 16 32-bit words, and then you're going to have 16 32-bit words for the initial, and then for the working, we're going to have to initialize these constants somewhere in memory. These can be done on the same on these. So you might end up using more than 40 total bytes, but at the end, when you're cleaned up and the next functions are being called, you don't want any memory allocated, if at all possible, especially when we're looking at tailoring this towards the UTF-S file system or the MUTF-S file system, which we are intending to be working on small embedded devices. So let's finish out our header. Oh, what's that? Buffer too small. So if the buffer they give you, the caller gives you, is not big enough for the data, we want to return immediately with that error, because if it's too small, we're either going to overwrite or lose data. And again, both of those are bad. We just want the correct call in. So this is our XCP result T. So when any of those functions have this data type, they're going to return one of these 4 values. Now we just need to define all of the functions that we are already calling, in which we can just copy and paste those. So let's open. So now whenever we have something that has a result, XCP result T, like these functions, they're going to return one of 4 values. They're going to return a 0, which means it was okay, a 1, which means there was a parameter error, a 2, which means there was an authentication failure. We haven't gotten to that yet, but when we get into the XChaCha20 Poly1305, the full construction, the full authenticated associated data construction, that will be a valid thing that we will use. And then the XCP buffer too small. So we really want to be careful about how much we're passing in, because if we don't give us enough space and let's say we want to encrypt 128 bytes and we give us a 120 byte buffer, again, we're either going to be writing into memory that we don't have the rights to access, or it's just going to truncate us and we are not going to have anything after that point, which is just going to be 8 bytes of lost data. That's terrible, both for our user and for that data is not recoverable. So if the buffer's too small, we want to figure that out immediately and return. Now we just need to copy in the function definitions from the real implementation file. So